friends, welcome to the second part of the linked list series. In this video, we will again cover from the basics to hard level. First, we'll be seeing how do we merge two sorted arrays. Then we will actually solve a mid-level concept. Then we'll be solving this problem. This is actually a hard level problem in LeetCode, and this frequently gets asked in FANG companies. Okay, so I will also mention the topics that was covered in the previous video. It is basically from very basics to medium level, then we again go on to solve hard level problems. So if you had watched the previous video, please do considering watching the previous video. So without further ado, let's dive into the first problem of today's session. So in the first problem, you are given two linked lists. So these lists are sorted individually. So if you look at the first linked list, it is sorted 5, 7, 8, 10, 30. It is sorted in the ascending order. Similarly, if you look at the second linked list, it is sorted again in the ascending order individually. So what is the task? The task is you have to merge these two in order to form a sorted linked list. For example, this will be the linked list. Having these values in this order, you have to form the linked list. So what are the choices that we have in front of us? One choice is we will put all these elements into an array list. Okay. So this is how it will look like. We put all these elements into the array list. Then we will actually sort it out. Then we actually form a linked list out of that. So if you look at this, this is actually quite space consuming and also time consuming, because you are putting all the elements into an array list first, then you are sorting, then again actually you are forming a linked list. So this is actually quite time consuming. We need not use that procedure. So now I will be discussing a procedure which will not need space complexity. It just needs constant space, and we'll also be solving in 0n time complexity. So how do we do that? We will actually do it in 3 steps. Let me discuss the first step. The first step is pick the smaller element of the two nodes. That is, we'll pick the smaller element. So which one is the smaller element of these two? 2 is the smaller element, and this will be our answer, the head of our answer. So we will just remove these pointers, and this will be pointing to the next node. So this is the first step. What you will do, you will pick the smaller element out of these two and remove it from there, and you will make this as the answer node. Okay, so as mentioned in the previous session, we should not move the head pointer, so we will call one more pointer, that is the iterator pointer. Let me just bring in one more iterator. So we will initiate the iterator to head pointer, so both of them are pointing at 2. So what do we do next? So we have got what our head will be. Next, what do we do? So the next step will be, until one of these lists is not empty, that is both of these lists have element, what we will do, we will pick the smallest element and we will just place it here. So which is the smaller element of these two? 4. So what do? We place 4 here. We will remove the connection, and this will be pointing to the next node, and we will also move the iterator. So I will explain you through the code, but I'm explaining you the concept now. So what is the next step? So again, which is the smaller one out of these two? 5 will be the smaller one. So we place here 5. We remove this particular pointers, and this will point to this, and our iterator will move. So again, the smaller element of these two is 6, and this will be going this, and this will move. So if you go on like this, what is the next element? So 7. We will just be removing 7, and you can actually place the other 7 also, it won't cause a problem, but just to show you one more scenario, I have placed this 7. So we'll remove this. Now if you look, this is empty, right? So we will stop this procedure. We will now, there is no element in the h2 linked list, right? So what we will be doing is, whatever this is, right, we can just pick all these elements at one shot, and we will just place it here. We'll pick all the elements and we will just point here. Okay, so this is the procedure. If you look here, this is now completely sorted. So step one, you will form, which is the head. You will just pick up the head. The second step, the first step is you will pick up the head. What is the second step? Until one of them has the elements. Sorry, until both of them have the elements, you will pick the smaller element and you will place in the next iterator point. Okay. So what after that? If one of them doesn't have the element, the iterator dot next, that is, we will be placing all of them at one shot at the iterator, and let it be here, and just we will return the head answer. So here we have a sorted linked list. Let me take you through the code. So this is the problem. Let me explain you the code. So these are the base condition, that is, if both of them are null, we have a special condition here. So we will just return null. All right. And if even if one of them is null, we will just return the other head, right? Because we don't have anything to merge. So these are the corner cases that we have to look. So here, the first step, what we are doing in the first step, if the head 1 is lesser than the head 2, our new head, this is our answer head, will be equal to h1, and h1 is equal to h1 dot next. What does this do? It will remove the pointer from the smaller element that it will place in the next element. That is, in this case 2 was here, right? So it will remove this and it will place to the next element. So this is the first step that we'll be doing. In the second step, that is, both of them are having elements, what we do, we check the smaller element and we place it next to the iterator. That is, we bring it here from here, that is, say it was here, we will bring it here, and we will also move the iterator to the next point. So that is what we are doing, and also this head will be moved to the next point. That is, this head pointer will also be moved to the next one. So that is what is being achieved in the second step. So in the final step, if there is any remaining thing, what we will do, we will just like if we brought all the elements together, we will bring them at one shot and we are done. So this will be our new head. So let me run this particular solution. And also submit this. So yes, so actually this was a easy level problem. So now let's get into one of the medium level problems, that is, you have to sort a given linked list. So this is the problem. So you are given a linked list, you have to sort the linked list. So usually people first learn merge sort using an array list and then come to linked list, but I think it is very intuitive with linked list, and it is much more easier than an array list to use merge sort with a linked list. So I will try to explain this very simply. Let me just get into the problem. I will try to explain my best very easily. So first of all, merge sort. What do you mean by merge sort? Okay, merge sort is actually a divide and conquer algorithm. What do you mean by divide and conquer? So first we do have this array. This is the input for us, 75364 361. Okay, so how do merge sort work? It will divide the problem into two. It's just like you are having a work, you will give it to two other person and they will do the task and they will give it back to you. So exactly this is what it is doing. So it will divide the array into half. This will be the first half. We will discuss on how it is done and everything, but just try to understand the concept here. So we will divide this into two parts, the first part and the second part. Then we will send it here. Okay, so what do we do now? We will sort them out individually and we will merge them. What we did in the last step, we did merge them, right? So what do we do first? We will sort them. How do we sort them? If we sort them, what will be the answer? 3, 5, 6, 7 on this side. And what will be on this side? 1, 3, 4 and 6 will be on the other side. So now what do? We just merge them together and we have the final answer, right? But one more important observation that you have to look here is, how do we sort this arrays actually? I mean our linked list. How do we sort this? Again, we use the same procedure. That is, we divide them into two parts. If you look here, this will be one part, this will be the other part. This is first part, this is second part. Again, similarly on the right hand side also. So once you have divided, again we have two elements, right? So what do you do again? Again we will do the same procedure, that is sort them and merge them. But if you look here again, since these have two elements, is there a possibility that we can divide this further? Yes, there is a possibility. How do we divide? 7 and 5. And again, we will divide 3, 6 so that each element becomes 1. So what after this? What after this? So one important observation you can look is, if the element size is just 1, what is the idea? It is already sorted, right? For example, if there is just 7, or think if it is just null, what does it mean? It means it is already sorted. So for example, here if you look, is 7 and 5 individually sorted? Yes, they are exactly individually sorted. 3 and 6 sorted? Yes. 4 and 3 sorted individually? Yes. 6 and 2 sorted individually? Yes. Now comes the magic of this algorithm. What do? We merge this. What do we get when we merge this? That is what we discussed here, right? What do we get? We get this sorted array. So 5 and 7 is sorted now, 3 and 6 is sorted, 3 and 4 is sorted, and 1 and 6 is also sorted. So what do we do now? We merge them again. How do we merge? We discussed in the previous step. So we get this linked list after merging, and on the right hand we get this, and as the last step, the final step, we merge again these two, and here we have the final answer. So why are we even using this procedure to merge, right? Cannot we use any other sorting algorithm? But this just takes n log n time complexity, and this is faster than any other algorithm. So in linked list we use this particular algorithm. So another way of doing this is very easy. Again, we can put this into an array or an array list. We will sort it out, then we can again form this array. That is also possible, but this is a very easy procedure, and this often gets asked in the companies. So how do we achieve this? How do we achieve dividing a given linked list into two parts? And how do we actually achieve merging these together again? And what are the base conditions that we want? That I will be discussing now. So this was for the previous problem. So merge sort. So here I have mentioned, that is, we will be splitting the array into two sort parts. We will sort them separately and merge them again. I hope you understood this part. So how will you be splitting the array? The second thing that you need to understand is, how do you split the array, right? So how do you split the array? In the last session we did discuss something, right? If you remember, how do you find the middle element of the array? In simple, we have a fast pointer, and we also have a slow pointer. So the fast pointer moves at 2x speed, and the slow pointer moves 1x speed. So it moves 2 steps, 1. Again it moves 2 steps, this will move 1. So if there is next, what will be the middle element? This will be the middle element. So we got which is the middle element of these two. So what do? We will act this as the first part. So how do we define the head 1 and head 2? Head 2 will just be equal to middle dot next. So let me show you the code for this. So yes, so we get the middle node, and what will be the next part? Head 2 will just be equal to middle dot next, and don't forget to remove this connection. Middle dot next will be later null, right? First thing you have to do is head 2 will be null, that is, you will place this here. The first part you will bring it out here, and the second thing that you will be doing is you will remove the connection between these two. That is, you will remove this particular arrow, so they are actually split. So the first thing that you need to find is the middle element, then assign head 2 is equal to middle dot next, that is the next element from the middle. Then you have to remove this connection. So once you have done that, here you have two different arrays, linked list. So what do? Once you have, you will repeat the same procedure. You will call the same function again with the same thing. So again it will find the middle and it will split it. So you will be calling recursively again this same function with both h1 and h2, right? So it will split and it will call this same function again and again. Let me show you the problem here. So here is the sort list. Again, this is the base condition that we have. The first thing that we will do is to get the middle element. Once you have got the middle element, we will define what is h2. h2 will just be equal to middle dot next, and we will remove the connection. Then the new h1, we will call again the sort list with the head, right? And again h2 will also be sort list h2. If you look here, this is h2. The new h2, what it will be, it will just be sort, and 1 will come here, 3 and 4 6, so it will be the new head. So it will be the same linked list but a new head. Similarly, h1 will be the same linked list but it will have a new head. Okay, I hope you got this point. So what are we doing here? We are recursively calling with the two new parts. That is the first part and that is the second part. With both of them, we are again calling them so that they will actually form a branch and they will merge individually. That is, the first part is sorted out individually, the second part is sorted out individually. And what do we do after these two parts are sorted out? We just merge them. This function, what we defined in the previous example, this is what we designed in the previous example. So we will just call this function. Yeah. So once we call this function, the array is sorted out. I will repeat whatever we did. First is we will split the array. How do we split it? We get the middle element. Once you got the middle element, the head2 will be equal to middle dot next, and we will remove the connection so that h1 and h2 are formed. Now what do you do? h1, we will sort it out individually. The new head will be the sorted head. It will be the same linked list, but the sorted head will be the new head. Okay. Similarly, h2 we will sort it out, but again the new head will be the sorted head. After that, we will just merge it. If you look in the example, we individually sort this out and we will just merge this. So I hope you understood this problem. If you have any doubts, please do put it in the comment. And let me submit this function also. Yes. So I hope you have understood these two problems. Let's get into the next problem, that is merging k sorted linked lists. Okay, so what are you given in this problem? So you are actually given a list of linked list. For example, you are given 4 linked list. Okay, so this will be h1, h2, h3 and h4. What do you have to do? These are sorted out individually. 159 is sorted, 346 is sorted, 278 is sorted, 416 is also sorted. So what do you have to do? You have to merge all of them. So what will be the final answer if you merge all of them? So if you merge all of them, 1, 2, 3 and something else, but all of them will be in the sorted order. That is what you have to do, and return the completely sorted. I mean, this doesn't look very tricky, right? Why is it actually a hard level problem? You can just merge first these two, you can merge it together. That is, this list and this list, you can merge it together. Then you will get a linked list of size 6. Then you can actually merge it with this list. Then you will get 9. Then again you can merge this, right? You can merge it in a linear way. Alright, then you will actually get the entire linked list, right? So you are given 4 linked list. You can just merge it one by one and you will actually get a linked list. Right? So let me explain you what is the time complexity actually involved in this particular solution and why it might be bad idea to do this. Okay, so what will be the time taken for you to merge these two? So it has 3 elements. So let us take n to be 3. It will take 2n time. Then after you bring it here, this linked list size will be 2n, this will be n. So what will be the time taken? So it will take 3n time to merge those of them, and again this will be 3n size now, and you want to merge these two. Again, what will be the time taken? 4n. Together, what is the time taken? Together 9n is the time that will be taken in order to merge all of this. Okay, it doesn't look like a problem, but if you look here, what is 9? What is 9? this is k, right? That is the sorry, this is k, that is we are given 4 elements. This, if you look closely, it will be k minus 1 square star n, that is whatever is the length. So it will take a higher time complexity. Now let us look into something similar that we have solved previously, and this is really beautiful. Let me show you how this works. Okay, so instead of, okay, let me keep this here. So instead of merging this one after the other, what if we do like this? Okay, let's first merge these and these two. Let's again merge these two. Okay, then merge all of this together. Let's see what is the time complexity. So first it will be 2n if you want to merge this and this. Again, if you want to merge this and this will individually take 2n time. And if you want to merge both of them, what is the time taken? That will be 4n. Together, the first one took, so together it will take 8n time. However, this previously took 9n time. You see the difference, right? It doesn't look like a very big difference in this particular problem, but let me explain this. What is happening here? If you look here closely, suppose we had 8 of them, okay? Suppose instead of 4, think we had 8 of them. If you look here closely, what is the time that is taken? It is just equal to 2n plus 3n plus 4n plus 5n plus 6n, so on up till kn times. So what is this simply? It is summation till k into n. So it is of the order of k square into n times. This is of the order of k square into n times. But if you look here at every stage, the number of elements is halving, right? So if we have 8, in the next we will have 4, in the next we will have 2, in the next we will have n. So what is the time complexity here? It will be log. So what will be the time complexity here? It will be n log of k into n. It will be k log of k into n. So we have reduced from k square to log of k with just by merging two of them together at once. And in the next stage we will do the same procedure. So let me take you through the code. So we are given a list of the head of linked list. So we are given the heads first. This is the first linked list, second, and the third one, and this is the expected output. Okay, so what do we do now? There are base condition first that we have to define. That is, if the list is empty, both of them are empty, what do we return? We just return null. And if it is not null, we are just converting this to an array list first. Why do we convert to array list? Let me explain. What are we doing here? We are checking the size of the list. If the size of the list is greater than 1, why greater than 1? If we have 1, we can just return the head, right? Because it is already sorted, as we know. If the size is 1, we will just return it. If the size is, however, greater than 1, we will merge them 2 at a time. How do we do that? So this is how we do that. We will define a for loop I, and how will I increase? I increases in steps of 2. So if you are at the index 0, 0 and 1 will be merged at once. Then again 2 and 3 will be merged at once, 4 and 5 will be merged at once. So what are we doing? We are getting the first head node, and if there is the next point, say you are at 3, if 4 is there or not, say you are at 2, if 3 is there or not. If 3 is not there, let it be null, there is no issue. This merge function will actually take care of that, right? So we have the same merge function that we actually defined in the previous problem. So if this is null, there is no problem. If this is a list, then also there is no problem, because our function will take care of that. Then what do we do? So our new head will be the merged head of this. Say for example, 145 and 134 is merged. 1 will be our new head, right? The head of this will be our new head, and you will add to a newly created list. Say for example, let me show you with this example. So initially, what is the head of these two? The head of these two will be 1, and the head of these two will be 2. So actually these two linked list will again be put into a list, and then we will repeat the same procedure again. So this while loop will be called again because the size of this is again 2. So this after merging will just form a single linked list starting with 1, and hence we have all of them merged. What is the final answer? We will just return the first element of this linked list, that is the head of the final result. So I hope this answer is clear. Let me run this solution and let me submit this also. Yeah, thank you for watching the video, guys. Please do like and subscribe.